So here first I'm changing my style of doing it. First we find all the derivatives. So we find here f of x. F of x is equal to 2x plus 2xy. Y is constant. Then we have f of y, x is constant, get here 2y plus x square. Now I need the second derivatives. Find f of xx. My f of x is 2 minus 2 plus 2y. My f of xy respects to y, we get here 2x, and then I take f of yy, my f of yy is equal to 2. So I get the first derivative and also the second derivative. Now, number one, I just going to discuss my critical points. To find the critical points, we find the gradient equal to 0, and the gradient equal to 0 mean the first derivative, partial derivative equal to 0. That's f of x equal to 0. And we put f of y equal to 0 and get two equations and solve it. So get here 2x plus 2xy equal to 0. This is my equation 1. And I having 2y plus x square equal to 0. This is my equation 2. So we have these two equations. We solve it, we get the value of y from the second equation. We get here 2y is equal to minus x square. I substitute the value of 2y in equation 1. So I get here this equal to 2x, get here equal to 2x. Then we having minus x into 2y, 2y is minus x square equal to 0. That give me here 2x minus x cube, minus minus become plus is equal to 0. Here is plus, so this will become here minus, not is plus, because here we are having already the plus sign. It's plus 2x and then it's minus x square, so become minus. So we take 2x x common, we get here 2 minus x square equal to 0. We get two values, x equal to 0 or 2 minus x square equal to 0. We solve this one. Our x square is equal to 2 and our x is equal to plus minus root of 2. So I guess I can find the value of y by substituting the value of x in this equation and put here x equal to 0. We're having here x equal to 0, we get y equal to 0. And we take here the value of x square equal to, get here 2y is equal to minus 2 and give me y equal to 1, that y equal to minus 1. So get the point as minus the plus minus root of 2 and minus 1, because here we substitute the value of x equal to plus minus root of 2 and then we just solve it. So these are the points. So this way expand it. So this means this is equal to root of 2 minus 1 and root of 2. There are 2 points here. We get here this one as a minus 1 and with the plus sign, and here we get here minus root of 2 and minus 1. So we get here the critical points. We are having 3 critical points. Our critical points are, because the function is a polynomial function, so these points are in the domain of the function. This is 0, 0, the first point. And then we are having here root of 2. Here, I'm sorry, this I rewrite again. This one here is equal to x is equal to plus minus under the root 2, because minus can't be in the root. Yeah, it must be outside. So it's 2, 0, and here minus root of 2 and 0, 0, 3 points. And here on these 3 points, we are going to discuss the extrema of the function. So here we find the discriminant to classify our points as a saddle point or the local extrema point. So my xy is equal to f of xx, f of yy minus fxy whole square. I have already calculated this one. I can use this one. f of x is 2 minus 2y. This is equal to 2 minus 2y. This is my f of xx. My f of yy is equal to 2 minus f of xy. My f of xy is equal to 2x. Is a 2x whole square. So I solve this one. Multiply by 2, we get here 4 minus 4y minus 4x square. Now I take the critical points. The first critical point I'm going to take is the critical point 0, 0. The x equal to 0, y equal to 0. When I calculate the discriminant at point 0, 0, so this is equal to 0 minus 0 minus, here we're having 4 minus 0 and then minus 0. The value is equal to 4 and this is bigger than 0. This means we're having local extrema at this point. So I check the second derivative. My second derivative here is f of yy is equal to 2. So I can just write here my f of yy is equal to 2. Here f of yy at the point xy is equal to 2. And if I take it the point at the point 0, 0, Again, this is equal to, at the point 0, 0 is also equal to 2. At the point 0, 0 is equal to 2, which is bigger than 0. And bigger than 0, this implies local minima. So the point we are having here, local minima at the point 0, 0. Now we want to discuss at the other critical points when you are having root of 2 and 0. This is number 2. We take here the critical point, root of 2 and 0, and find the values of our discriminant at point root of 2 and 0. Y is 0 and x is root of 2. So we're having here, we get here the value as we can substitute here in this one. We get here 4 minus 0, and minus here we have 4 into root of 2. Root of 2 is equal to 2, and get here 4 minus 8 is equal to minus 4. This is less than 0. This means here saddle point. So this is not maxima, this is not minima. We don't need it. We are looking for the local minima. So here we take the third critical point. Our third critical point is, and we discuss on this critical point the discriminant and also this minus root of 2 and 0. So discriminant of minus root of 2 and 0, we substitute here. We get here 4 minus 0, and we get here minus 4 into root of 2 squared is equal to 2. Again 4 minus 8 is equal to minus 4, again less than 0. And if it is less than 0, this implies we are having a saddle point. So we get only one point where we get the local extrema and local minima. So we are having local minima at the point, 0, 0. Now I can find the value of the d. The d is my value at the point xy, the value of the function at the point. So we having this point is xy. So when we take here this x, y, and z, the function we have defined, that was here x square plus y square plus z square. And then when we rewrite our function as a function of xy, so this function of xy is equal to, we're having x square plus y square. Then we put the value of z square, where z square value was equal to, we were given here, z square is x square y minus 4. So we get here this equal to x square y minus 4. So this was here having the root sign, and we say this was also the root sign for this was my d square, no d is having the root. So my d is equal to, when we take the values of x equal to 0, y equal to 0, then this was, we were going to find the value. This was, the value was plus 4, not the minus 4. And let me check if I have is correctly taken. No, this is not minus 4. This here is plus 4, and I make it also plus 4. So this is not making any difference on my calculations which I have done. So here I just make the substitution. We get here root of 4, and this is d square. D is root of 4, and when I find the value of d, then my value of d is equal to 2. So this is my minimum distance between the point and the point on from the surface. Z square is equal to x square y plus 4. Thank you very much.